Hi everyone, my name is Balassi Musavi and I'm going to give a talk on dyscalculia and maths education for SEN students. To start off, just to give you a little introduction to myself, I'm currently studying maths at the University of Birkbeck, and I'm also head of maths at Abingdon House School, which is a specialist provision in Westminster for students with a range of learning disabilities such as autism and ADHD. So, in terms of learning difficulties, it's highly likely you've heard of dyslexia as a learning difficulty that affects reading and spelling. But have you heard of dyscalculia? Research into this is about 30 years behind dyslexia. The British Dyslexia Association defines dyscalculia as specific and persistent difficulties in understanding numbers. Um, it presents for educators and for learners a significant long-term challenge to the education. As mathematicians, we understand that mathematics is a cumulative subject where ideas build on each other. So, not having that mathematical foundation can present significant problems to students in terms of acquiring higher level skills. Just to put it into context, within the UK population, it's estimated that around 25% of people have a maths learning difficulty, which is pretty high. And of those, 6% have dyscalculia. Interestingly, 60% of the people with dyslexia also have difficulties with maths. So there's quite some crossover in terms of the learning difficulties. In terms of the causes, they're quite varied. Learners might have other neurodiverse conditions or a comorbidity, such as ADHD, ADD, or autism. The difficulties may stem from some kind of traumatic experience within their educational history and the subsequent maths anxiety resulting from that. Or it may be as a result of conditions such as fetal alcohol syndrome. So there's quite a lot of different reasons why people might have them. Okay, so as the next part of the talk, I'm going to talk about some of the key features that learners with maths learning difficulties have, and then talk about some of the educational strategies that we might use to overcome them. Okay, and the first feature I'm talking about is number sense. So number sense is a key, it's a foundational mathematical skill. It's an understanding of what numbers are, what they represent, how their relationship with each other, their order. Without this, learners find difficulty in accessing topics such as place value, ratio, proportional reasoning. It's a fundamental skill that we learn at quite an early age, which becomes the foundation for our understanding of maths. Okay, I'm going to show you some circles here very quickly. How many do you see? Okay, did you see them? Okay. If you saw three without actively counting, then you were subitizing. This is a skill where we can recognize the average population can do it up to about four items. They can recognize items without actively counting them. Um, People with maths learning difficulties find it very difficult to subitize and can only do it between one and three items, which obviously clearly presents quite a difficult problem. Fortunately, subitizing is a skill that you can develop. So some strategies that are used can be dot patterns and representations on numbers on flashcards, which students can learn. If we subitize above about four, we're usually basing it on pattern recognition. So, for example, on the right, you can see the Hungarian number frame, where the five represents the five on a dice. We recognize the five there because we recognize the pattern. We're not actively counting them. So, using flashcards and developing those subitizing skills is key to working with those learners. Perhaps one of the fundamental strategies when it comes to working with students with maths learning difficulties is taking a CPA or a concrete pictorial abstract approach. As we know, a lot of mathematical skills are quite abstract. We use abstract representational symbols to represent ideas. When we see 2 plus 3 equals 5, we don't actually see two items. For students with learning difficulties, these abstract things are quite difficult to conceptualize. So the way to deal with that would be to start off with a concrete foundation where they can physically touch and handle the items so that it becomes real and concrete to them. Progressing on from there, they move on to pictorial representations. So as you can see in the middle picture, we've got here a structure called a part whole model. It represents that 2 plus 5 2 plus 3 equals 5, showing the parts that make the whole. Students can still, in 2 dimensions, count them, but it's one step on from actually physically counting them. And then from there, they can progress to abstract number sentences that represent the act of joining 2 plus 3. Okay, the second feature that I'm going to talk about is difficulties with working memory. For many students with learning difficulties, they can achieve greatly in maths and go on to study quite high level maths, but there's certain adaptations that they need in order to solve more complex problems. So in terms of working memory difficulties, solving multi-stage problems can present a challenge because it requires that learners hold more than one piece of information in mind at the same time and puts quite a burden on working memory. Um, so when it comes to those multi-stage step problems, it can be difficult to go from the first to the last piece and keep everything in mind. Strategies involved in this might include visual support or chunking of information, by which I mean breaking the information into more manageable, shorter, achievable steps. My student here, Gabrielle, you can see Gabrielle has amazing facility with maths. But in order to solve some of the higher level GCSE problems that he's solving, I support his learning by breaking down the problems into steps. So a ratio problem here becomes a series of steps involving describing the ratio, calculating the total number of parts, and then using the visual support of the bar model, which is a Singaporean structure that's being adopted increasingly in UK schools. This represents the parts of the ratio and the proportions. So it helps Gabrielle to go from taking in the initial information to doing the final calculation. So he can achieve quite complex problems, but with the support of help. Another strategy for supporting that goes along with the CPA approach is to create mathematics as a tactile learning experience. My student here, Angelica, is ordering 7-digit numbers, which is, pretty good in terms of the numbers. But she's physically lifting them up so that she can represent them on a line, rather than just having to look at the digits between each, which would represent a lot of digits. She can physically manipulate that item and put it in the order, that she wants to. Another one of my students, Zach, as I mentioned with the CPA approach, maths education is seen as something that can be multisensory, that you can touch and you can feel. Having a variety of different senses in which you get the education makes it more memorable for the learner. So my student Dax took part in a study that involved GCSE geometry, looking at ways to teach teach students with autism to understand geometric structures and views. And doing it, you can see with the concrete apparatus, really helped him to be able to see that. And in terms of his achievement, he moved on from GCSE with me, and now he's doing A-level maths and A-level further maths, as you can see. So having the maths learning difficulties is not a barrier to achievement. Another student that I worked with, Eddie, he experienced significant educational trauma in his earlier years, specifically in relation to maths. So he found it very difficult to participate in maths lessons. He was very worried about making a mistake to the extent where he missed a significant chunk of maths lessons. But in recent years, since he came to my school, we've supported him with a range of strategies, such as you can see on the left, where he doesn't have to commit to writing a certain number on the page that might be wrong, but he can lift the physical paper. With Angelica, it was making a tactile experience. With Eddie, it was making a low stakes experience where he can take a risk by putting a number in the box that he thinks is correct. And as you can see now, he's a lot more confident and he's willing to take risks. He recently took part in the UKMT Intermediate Maths Challenge, which was a delight to see because it's an optional maths exam. Um, but yeah, so he was able to overcome that with these strategies. Okay, so to finish, the key takeaways from this then, as defined by the BDA, these kind of learning difficulties and dyscalculia do represent significant long-term challenges, both within specialist settings and SEN schools and also within mainstream schools. Um, some of the key features that I've mentioned today could be number sense, and the difficulties that come from not having that foundational understanding of what a number is, but also working memory in terms of being able to solve more complex mathematical problems that involve multi-steps. But as you've seen from the examples of my students, with specialist teaching and understanding of students' needs, we can see that these learning difficulties are not a barrier to much achievement in maths. And probably one of the best things about my job is being able to support students to achieve their best and to enjoy maths. Um, yeah, so thanks very much.